right, I just want to give you guys some few brief pointers on worksheet 1 here. So this function here, differentiating that is going to be very similar to that example on the quiz a couple of weeks ago that I noticed a lot of people really overthought it. So just keep in mind, we want to try and optimize the function or simplify the function and prep it for differentiating. All right, if you want to run the quotient rule here and the quotient rule there, you can, but that's going to be a lot of work. Just keep in mind, through properties of exponents, division by x to the fourth is the same thing as x to the negative 4. And this is x to the 3/5 in the denominator. So with negative exponents, that's x to the negative 3/5. And looky there, from there, all you got to do is your power rule, which I think is probably everybody's favorite rule when it comes to computing derivatives. Then it takes us, like 2 seconds. So you want to work smart, not hard. Now, the main focus for these derivatives is just working with exponentials and logarithms, which we covered at the beginning of quarter 3. So in case you need a little refresher, don't forget that reference sheet with your common derivatives. There's your logarithm, or natural logarithm, and base A logarithm. There's your base A exponential and your base E exponential. So just keep that in mind. Reference these, basically from here down when computing these common logarithms here, until you get to 7 and 8 with this arc cosine, arc sine, arc cosine of x. So those are your inverse trig functions. So if you want to, review your, where are the inverse trig functions? Those also are on, let's see here, your common sheet. Where are they? One second. Oh, there they are, right in front of me. So again, you can reference your sheet from there to there. These are your inverse trig functions. Remember, sine inverse is the same thing as arc sine. Inverse cosine is arc cosine. Inverse tangent is arc tangent. So you're using just these 3 identities along with the chain rule and the quotient rule on problem 7 and 8. So again, make frequent use of this sheet. Then on the back side, we have an application of the extreme value theorem. This is a continuous function on a closed interval. Therefore, we do have absolute extrema. So you want to look at your left endpoint in the region. So, plug in 0, see what you get. You got your right endpoint. Which is plug in pi, see what you get. And then from there, you need to do your first derivative test. So your first derivative test is going to be computing the derivative of that. So you will need to run your product rule. And then set to 0 and solve. Now when you set this to 0 and solve, you want to factor out the exponential. So you'll have 2 terms when you use your product rule. Both of them will have an e to the x. You could factor that out, and from there think about when would this equation be 0. That will give you your extrema in the middle of the endpoints. But I digress. Let's look at the last question, which is a related rates problem. So you got a nice picture here, and it's basically asking us find the rate at which the angle of elevation is changing. So we want to find theta prime. But first we need an equation, and we know the speed of the plane is 600 miles per hour. So that tells us the plane is going 600 miles per hour in that direction. So that is your dx dt, your x value changing. So we want to come up with an equation between theta and x, and the simplest one is going to be tangent of theta. Remember, tangent is opposite over adjacent, so 5 over x. And from there, you would go ahead and do your implicit differentiation. Differentiate with respect to time on both sides, and do your derivatives from there. And from there, you can solve. You will be working with trig functions, so again, you might need to reference, your derivative of tangent. In case you need a refresher, there's your derivative of tangent. Just don't forget the chain rule, your theta prime, essentially, when you differentiate. And you'll also be evaluating trigonometric functions. So don't forget, if you're a little bit rusty, try and work towards memorizing it. You want to reach a point where you don't need this anymore, but if you're a little bit rusty, always remember the trick to evaluating trig functions is your unit circle. So if you need a reference there, unit circle, it is there. And if you've lost those blue and white reference sheets, they are posted on Google Classroom for your perusal. But there's a few tips and tricks for the homework, and I look forward to seeing you all in class. Keep up the hustle.